Hello. I guess it's still minutes to go, but I'll just get started with what I have to say. Yeah, hi everybody. Welcome to this Tuesday seminar talk. Thanks for taking time out of your normal schedule. And yeah, so this is my third year review talk. I was able to crib Joe's notes from yesterday, which was helpful. And I am happy to share all the weird stuff that's been going on for me the past 3 years. Because basically, long story short, probably didn't really go too far into this, but it turns out starting a professorship like right before a pandemic is like a really weird time to do that and affords some certain challenges. So I'm going to be giving so the roadmap for this talk is going to cover in service of third year review types of things. I'm going to talk about my research that I've been up to, teaching plans and teaching stuff and then service. And the research is going to be split into roughly 2 paths, corresponding to roughly the 2 timelines that may have occurred. The first stuff is sort of the original plan. Like this is kind of the stuff that was sort of planned at the time that I showed up. It's my traditional line research, sort of visual control of locomotion, stuff that I got the ROO to come in for continue, visual control of foot placement stuff. At the time, I was sort of imagining myself following a relatively traditional approach to research, which involves like doing research, publishing in journals, and all that sort of normal stuff. And then timeline 2 is what actually happened, which is sort of whatever the current situation is. And both sort of research lines for me are kind of overlapping with themselves. So I'll start by talking about the traditional stuff. There'll be a bit of a gap, sort of timeline gap in there. And then I'll sort of wrap around and talk about what I've been up to. That will sort of, and all that will kind of lead directly into the teaching and service and all that kind of good stuff. So let us start with timeline 1, the original plan. So when I showed up here in summer 2019, I guess the first time I was here, I gave a job talk in 2018. I was talking happily about this kind of stuff. So, which apparently is not playing normally, because nothing ever does. Anyways, well, we'll see if that's a problem. So you can Google this if you want. Just Google last name, laser skeleton. Oh, there you go. So imagine this, but it's data. That's basically what I did in my postdoctoral life. So this was from UT Austin, sort of walking outside, and this was playing with show an eye tracker, sort of view from the head and then crosshair shows the eyes, and then full body motion capture with lasers coming out of its face, affectionately known as a laser skeleton. And so my plan coming in was to sort of continue this line of research. And this is the slide position that sort of, this is what I was hoping to do in like summer of 2020, but instead it's like a month old. The plan was to sort of engage in this kind of like virtuous cycle of combining sort of outdoor research with sort of all the richness of the outdoor world and all of the sort of like, ecological validity about that kind of stuff. But with the lack of experimental control, this kind of data is good for sort of methods building kinds of stuff, and then sort of hypothesis generation. And then once you have a sense of what you're sort of looking for, then theoretically you can go into the lab and then run some kind of more controlled experiments. So this is, actually I guess that looks like Mike, I thought that was fine. This is from within the past 6 months or so, but this was the plan for what the research that we were going to do. This is an offshoot or sort of updated version of what I did in my dissertation, where you have a bunch of projectors pointing at the ground. They are synchronized with a sort of big traditional motion capture system. And then for this particular experiment, I lost the presenter. the task at hand was walk across the terrain and step on the targets, which are little C's, and avoid the distractors, which are O's. I also should say at this point, I have just plopped a presentation from Trent into this presentation. So we're not going to be going over it in detail. It's going to be more of a shock and awe campaign of all the fun stuff that could have happened. So none of these videos play. Okay, good. So this is, I guess that's me recording some data, some sample data. I'm wearing a laptop on my back, which is tracking my eyes like a normal person, and doing this simple task of step on the targets, avoid the distractors. This is the basic layout. So this is the traditional motion capture system. I keep saying traditional motion capture because foreshadowing. And this is eye tracker, otherwise known as Dr. Trent Worth, who is my postdoc. And he's been doing sort of a lot of the work, sort of keeping the home fires alive and sort of keeping this project moving forward. So this is a view from the eye tracker in that task. And again, I'm looking for C's and avoiding O's. And the O's are just distractors. And so you can kind of see that this kind of search pattern that's occurring as I'm sort of following through this task and sort of fixating on the targets I need to fixate on to complete the task. And then of course, in what's now sort of something I've come accustomed to, you can take the head-centered video and then reproject it so that the fixation point is always at the center, which basically casts the visual information into a retinal-centered frame of reference, which is very nice for the sort of neural visual control of visual neuroscience we have, because V1, which is the primary visual cortex, among other areas, are retinotopically organized. So this is the frame of reference that the sort of visual system gets information in. So if you were a Peter Beck's type object, I believe I saw it being into the area of the Zoom space. This is kind of the reference frame that you would want to sort of see the data coming in, so you can sort of interpret the task-based aspects of this this behavior. And then you could take all of that good stuff and sort of pull it together, and then if you're trying, you can do all the work that needs to be done to sort of pull together like data streams, synchronize them, calibrate them, pull them together, and then get this sort of lovely little laser skeleton, which is a full body motion capture. And the two layers represent point of gaze, where the black dots are targets and the white circles are distractors. So you can kind of see that search pattern that's happening. So one of the downsides of using your postdoc's slides is you don't know where they come. So I will switch back to this. There we go. So, so that was the plan for roughly summer, fall of 2020. This was kind of the work that I was hoping to do. And again, this was work that this was this visualization was Trent's work for the Visual Sciences Society Dynamic Walking Conference that happened this summer. So there was a time gap there. I don't have too much more to say about that, both because there's not too much more to say about it, and also because I want to talk about other stuff. This is the kind of thing, sort of in the spirit of what's to come. We absolutely could have cranked some data out of this thing and published a paper, but we instead chose to scrap it and refactor from scratch, so that the Unity project that is underlying this task will be shareable, and it will be actually like a reproducible methodology that can be shared with other people. Also, we wanted to change stuff about the design. And we do in fact have some people sort of waiting to take that.
Why are the traditional motion capture data not shareable?
The data is totally shareable. Yeah. The code, the Unity environment to make the experiment is, well, it was not really clean enough to be like usable. And to be honest, the data themselves were fine, but the analyses also were sloppy. They were, academic spaghetti code. That's the way that we have all been sort of pseudo trained to write code. Is, I'm sitting in my computer, I can get it to run. if there's like a grad student next to me, maybe I can get them to get it to run. But there is a very big difference between things that people in lab stuff that can that can allow people to sort of like do things kind of reproducibly in a lab versus something that can be shared with other people and used sort of, without you being in the room. And historically, traditionally, we as academics don't worry about that. We get our stuff to some kind of stopping point. We make a publishable object. We throw it out into the world, 10-page PDF, and we're done.
But right now, if you wanted to publish this data, you do have to share the data as they underlie the analysis and the results
Sure.
that you publish, right?
And it doesn't
So
really,
it is doable and it's being done.
yeah, it's doable, but it's not really, we like to tell ourselves a lot of stories about the data that we share and the code that we share. And there's dozens and dozens of gigabytes of data involved with this. And there's some, you did a great job, but the MATLAB code behind it is not, like, it's not going to do anybody any favors. It's code needs to be iterated on. And this kind of like first past the post sort of minimum publishable object, that sort of methodology that we have sort of traditionally taken is just one of the many journeys that I've gone on in the past 3 years. And I just sort of adopted a certain approach that I will talk about in detail.
I have a question about this setup. The distractors to me look an awful lot like the targets.
Oh yeah,
That's
super
on
hard.
purpose.
Yeah.
Okay.
It's super
So-
hard. So the important, so the nice thing about this was that it's a parameterizable terrain. That's one of the things that needed to be refactored. Refactoring is code term for just like rewritten, is to make the parameters sort of more tunable and sort of more changeable. There's some hard coded stuff in there that would make it hard to say like, oh, I want to make the gap smaller. It's like a challenge. So maybe don't want to do it. Oh, the calibration has some sort of extra steps. So you have to like move the folder, change the name of the file, that kind of stuff. But the idea behind this and sort of the platform that's being built around it is a parameterizable augmented reality ground like AR, the tradition of just picking letters. But yeah, so the hope was to make it so that the idea is that you want to make the targets and distractors similar enough that they require fixation to be discriminated.
Okay.
If they're too dissimilar, you can sort of tell from periphery.
Okay.
But I mean, just to add to my previous question or concern, I mean, sharing data has become the norm, right? And we all do
Data
this,
is data, code is code.
but this is only in support of the scientific insight. So when you kind of refer to the papers that come out on data that are, well, arduously obtained, of course, and shared, after all, it's about the scientific insight and not about the data per se.
At times,
You can share your screen.
oh. Yeah, there's a million types of research with a million different perspectives. I have done plenty of work that involves sort of like hard to reproduce methods. It produces tremendous amounts of data. There are now, one person at least has now gotten his PhD in reanalyzing the data that I got in Texas, and another person is working on a postdoc. But there's different perspectives. And one of the sort of changes of heart that I've had is I just don't really want to be making methods that I'm the only one that can do it to produce data that I'm the only one that can make it. So I can throw it online. Here's a 70 gigabyte zip file you can download. Here's some spaghetti code that you probably won't be able to get to run. I've done my job. I'm a good scientist. Like, that's not my approach anymore. Not to say that anyone else should do anything differently, but this is what I'm up to.
I have a more technical question. How do you ensure alignment of your task space with your motion application? I'm sure it's very sensitive.
It is a whole process. It's complicated, and there's a procedure, and that's part of that is like part of the refactoring, sort of like making that reproducible and not something that's sort of like that somebody else could do. Calibration and synchronization is a newbie theme throughout the rest of this whole thing. But it's complicated. We could talk about it, but I'm gonna move on.
Yeah, I'm just wondering if we maybe almost like a function of the variability you see in the eye tracking.
So the eye, okay, so there's a lot, yeah, there's calibrating the eye tracker, there's calibrating the projector, calibrating the projectors to qual assist, there's calibrating qual assist for the pupil labs. And there's a procedure for all of them. It's complicated. We have a lot of tests, but I'm going to move past this part. But that is, in fact, the right question. So yeah, also pre-COVID, plans being, my plan was already to kind of branch out from locomotion at the time. I had kind of very strongly branded myself as like visual control of locomotion, laser skeleton, walking on rocks, that kind of thing. And the plan was, it still is, to sort of branch that out and sort of more generally neural control of full body movements in the real world. Walking is a really beautiful thing to study because it has these really nice handles on it. It's repetitive. We know a lot about it. Sort of like physics are pretty obvious. And so my plan was to kind of use the tools that I had developed and skills I had picked up to kind of like branch out into thinking more generally about human movement in natural environments as a whole. And I was even starting to pull in some folks, some people in the room were here for that. This is Steve, who's a local circus performer performing a steer wheel. That's data that was recorded in the lab. And this is a Blender animation. This is the first of many Blender animations that I think Jackie Alex for being sort of, she started in the lab, one of 4 co-ops that joined my lab in January of 2020. Boy, I had plans for them, and we did different things. But Jackie is an animation major, and she wrote everything that you see that had Blender in it was sort of based on her original sort of exploration into that. Blender is a 3D animation software, free open source, codable by Python, all that kind of stuff. She actually just, doesn't mind me saying this, but she just accepted a job after she graduates for a small animation studio called Pixar. So there you go, Jackie. So that was the plan. And sort of what I showed you was sort of like 2020 and then like a couple of years of gap and then sort of like getting back into it. And now I'm going to show you sort of more aligned with sort of what actually happened. Because what actually happened was I hired a master's student and 4 co-ops in January 2020. The expectation sort of going into this like fancy new physical space and doing a whole bunch of work to sort of get my traditional line research up and running and start pumping out the papers like we're supposed to do. And then instead, the world exploded and I lost access to my physical lab space for nearly a year. And so in that time, I sort of had, there's a lot going on in the world, there's a lot going on with me, and I sort of had a lot of changes of heart. Some of them were practical. One was just, I needed something further to do with my students while we didn't have access to labs for an unknown period of time. So I picked up this kind of approach towards looking at a tool that I sort of discovered in 2017 called OpenPose, which OpenPose is the stuff that's driving this. It is 2D skeleton tracking, and then this is a calibration grid, and then tracking my body and doing sort of triangulation and getting sort of 3D skeleton from GoPros in my living room in the cutoff is I think June of 2020. And so the idea was it's like, right when the hammer fell in March, we needed something that we sort of turn around and sort of get like 4 co-ops and a master student worth of effort to work on. So we picked up this project as sort of like, hey, maybe we can see if we can sort of explore this idea that I had, whatever, 3 years ago, of can we use these kind of 2D tracking methods along with sort of traditional computer vision method techniques to generate a 3D sort of person. And that took, we'd already been working on it, and sort of that just sort of absorbed the rest of the lab. And then around June of 2020, we sort of got this, which was sort of the first proof of concept that you could in fact get that kind of data. However, what also was happening at that time was I was sort of kind of losing all of my faith in like the entire academic system and like, you know, society in general and all that kind of stuff. And I was beginning to have serious doubts about like the kinds of conversations we've had about like what do you do? Like how much good are you really doing as a scientist? That's not the wrong way to say that, but like how like was I personally doing the most good that I could with the skills and sort of privileges and positions that I was sitting in? Because at this point, like, you know, we could have done a study, we could have published something, we could have had the data, and we could have thrown it online and sort of given it to people, but no one would have been able to produce this kind of result because it was too fiddly and too specific and too just not robust. And in those sort of deep introspective moments of summer of 2020, I also discovered something interesting in this program called Blender. So I'm going to give a brief aside about so this is Blender, and this is a tool called the grease pencil.
I don't think you see it.
Thank you. There you go. So this is Blender is a 3D animation software, and this tool is called Grease Pencil. It's designed to sort of let animators come in and be like, oh hey, you know, look at this thing. It's a way to just mark things up. It's a 2-dimensional object in a 3-dimensional world. And there was a group of people in roughly like 2010, I think, that really liked Grease Pencil. They thought it was a really cool tool. So what they did is they forked Blender. They took the Blender software and they forked it, and they worked in parallel with the Blender proper, developing that tool into a fully fledged 2D animation method. Oh wait, no. And so what happened is over the course of 10 years, this independent group of animators working sort of collaboratively in their spare time, distributed over space and time, worked on this sort of extra tool, keeping pace with sort of like the mothership version of Blender. And then at a certain point, I think it was actually right around 2018 or so, the Grease Pencil sort of sub-community threw up a flag and said, hey, main Blender, we're ready for you to pull us back in. And then they did. And so Blender pulled the Grease Pencil thing back in. And now Blender has an entire 2D animation suite. And so looking at that, it was just kind of the realization for a personal revelation that that is a much better model for science than what we do of papers and universities and all this kind of stuff. The idea of just sort of working collaboratively in a decentralized way on something that once you were done with it, everybody gets to benefit from it in a direct, concrete way, was just a very inspiring thing to realize. And so that was when I kind of realized the open source community is what the animation community or what the scientific community kind of pretends to be. Let's see, share my screen again. And so that was sort of a revelatory moment that sort of then inspired me to sort of change my perspective on what I was doing with my research. And instead of thinking about sort of myself as like a traditional sort of scientist type, really wanting to start leaning in to the tool building part of it. So, instead of just collecting data that only I can collect and sort of doing the study that only I can do, maybe I should just take that same amount of effort and focus instead on really honing the tools that I was using and making it something that not just I could use, but that anybody could use. And so that was the beginning of the FreeMoCap project. Oh, and this was also, I learned I got pretty good at juggling. And so this is a post that I made to Twitter in July 21st. Twitter and Reddit and all that kind of stuff. I'm doing this. And then the orange thing is my hand, and the blue and red is, but no, orange thing is the ball, blue and red is my hand. A lot going on there. And I could have done studies on this. I could have published plenty of things on this, but I would rather take that time and just make the tool better and more usable by other people. And once again, lost. And so now I'm going to switch over to my grad students slides, because this is what I was like, oh, I got to put together slides about what FreeMoCap is. But this Aaron Cherian is my graduate student. He's a bioengineering grad student. And he wrote most of the code that was behind this, what we're calling the pre-alpha version of FreeMoCap, which is very impressive considering he came with no programming experience. We had like a little bit of MATLAB, but like we learned Python together doing this. This is in his bedroom with the two camera recording. And this is the side becoming exercise that he made as part of his work in progress seminar for the bioengineering program. And it looked like he made these just like he's like a design, he's like an engineering design person. And so, basic idea. So traditional motion capture, marker-based motion capture, you have cameras that are sort of in very specific places. You do what's usually a proprietary calibration methodology, and then you have these reflective balls that sort of are infrared reflective. And so the idea is that the motion capture cameras are sort of blasting this room with infrared. The reflective light comes back to the lens. It's the brightest thing in the room, so you can do thresholding and pick a point, and then basically you have calibrated cameras that are sort of have known 2D positions. FreeMoCap is sort of based on the realization that these sort of 2D skeleton tracking tools that the computer vision machine learning people are just kind of popping out, sort of like, this is actually like the machine learning community is just wild. They just sort of like any of the computer science side of the world, they just sort of like feels like they're just like chugging along, and they make these like magic tools and they say cool, and then they just like throw it out the window and move on. And so there's all of this sort of so like looking at this as like a human focused research scientist, I'm like, oh man, you can really use that for like real work. But then you actually start trying to dig into like using it as an actual scientific tool, and that turns out to be a whole extra challenge. So the FreeMoCap software involves a combination of sort of like the magic box part of the tool, and then a bunch of just traditional old school geometry, computer vision, synchronization. This is called Charuko board. It's like cutting edge 1995 kind of thing. And through the sort of careful collection of these different objects and sort of putting together into like clean pipelines, you can generate what I believe is going to pop up. Some very nice looking 3D skeleton. So this is my grad student in his home with 3 $10 webcams producing pretty nice full body motion capture data. And importantly, sort of one of the invisible things here is the workflow, because it's all well and good to have something that's like, hey, we get your little pieces, we could put them together. It's another thing to have something you can sort of push the button and get the data. One of the problems with the traditional MoCap system is that it's got like a massive post-processing step. like click on the dot and like, oh, that's my left shoulder. Like, and I turn around, it's like, oh, I forgot, I can't notice, I don't know what it is anymore. It's like, good Lord, like at the same time that I'm using this, I have to click on these damn dots to tell them that's my left shoulder, like. So anyways, but this you can get with $10 worth of webcams. And this is, sorry about the head. This is that same data being thrown through OpenSim, which is a musculoskeletal simulation software. And this is the same thing put back into Blender now through an automated process. So this is not fully automated yet, but the Blender stuff now does sort of come spat out directly from the end of the pipeline, which is very good for the, well, I'll talk about the community stuff in a second, but yeah, talk about that later. So, and this is where Aaron tries to convince me that motion capture is good and useful. It is for many purposes, and then limitations of the existing stuff and the old stuff. You know, I don't feel I need to convince you of that, but ask me. And so Aaron is currently working on the sort of validation side, because you have this fun new research tool. Is it valid? Is it accurate? Is it usable? And interestingly, as I've been sort of being very vocal and very public about this project, there's been a wide array of communities that have been interested in it. On the one hand, it's the scientists and the researchers and the clinicians and types. All of them are very concerned about accuracy and validity as it should be. On the other hand, you have the animators and the game designers and the artists, and they actually don't care if it's accurate. They just want it to look good. So, because they're just going to use it as reference data anyway. So it's been really interesting sort of like having part of the community able to sort of just like play around and have fun with it while we are in the process of doing this careful validation type of stuff. And so this is just a couple sort of tidbits of a process that we're doing, which is sort of going to be a combination of sort of postural control types of studies, where you have center of mass here, and then basis of course of I lean all the way to my left, and center of mass doesn't pass my left foot because the data would fall over. And this, and then I think this one is 1 foot, yeah. And so this is sort of provides both a very nice case of, it's an interesting sort of clinically relevant task because it's like standing posture, while on the same, at the same time being a nice validation tool, because we know from sort of theories of mechanics that, if the base of support is on top, is right under the center of mass, then the object can be stable. So I know that the center of mass of this phone is directly over my finger because it's not falling over. Similarly, if another physically wobbly object, am standing on 1 foot and I'm not falling over, then you know that my center of mass is somewhere in the column over my foot. And so looking at the sort of standing posture thing provides both an opportunity to do sort of clinically relevant sort of studies, while also just giving sort of a very nice validation to tell if the measurements are actually accurate. And it seems like they roughly are. And then you can do fun stuff like, if you're leaning too far back and then you actually have to take a step, you can sort of predict when that's going to happen because the center of mass crosses the boundary of the heel. And then, of course, you can compare the cheap FreeMoCap data to the very expensive Qualys data and say, how good is it? And the answer is, obviously, the Qualys stuff is better. It costs $250,000. But is it that much better? The answer is, it depends. Obviously, it depends on what your needs are. So this is showing the pink data is FreeMoCap, the gray data is Qualys. There's challenges here because you can never really know, like I don't really personally trust Qualys all that much. So like we say the Qualys is like the gold standard, but like I don't really actually trust it all that much either. But minimally, it's pretty good. So if you are asking questions that are sort of within the noise profile of the data that we're looking at, then you're good to go. If you want to ask very precise questions about like dynamics and sort of higher order movements, maybe you think about something else.
And so there's, amongst others, the black cut
Deep Lab Cut is just this. It just does 2D stuff.
I
And
don't think so. I mean, I know more, but
yeah,
I have seen recordings out of it.
yeah, and a lot of them are sort of this kind of like, yeah, you can make it happen. So Deep Lab Cut is a part of this pipeline. The juggling balls were tracked with Deep Lab Cut. I did some work with James doing some max level tracking. The main, from a technological perspective, I'm not adding anything to the pile. From a practical perspective, we connect the cameras. We do everything in one click. We can handle more than 2 cameras. We have altered the code underneath it. It's a smoothing out thing. Deep Lab Cut is and will be a part of this pipeline, but we're focusing on a different sort of perspective. Deep Lab Cut seems like they're more interested, like their focus is mostly like bringing the highest tech of 2D tracking from like the pillar of machine learning and computer vision and providing them to computational neuroscientists. And I know many computational neuroscientists who struggle to get it up and running because it is very difficult to make something easy to use. And they're also trying to like push the envelope in terms of like different algorithms and different yada yadas. We're just trying to make a tool that is sort of as accurate as it can be within sort of a number of constraints. Anyways, yeah, so very similar data. This is $60 worth of webcams. This is $250,000 worth of specialized equipment. It's better, but is it this many zeros better? That is a question between
But
you.
just because, I mean, there's a lot of interest. I know,
Not
but
the
also
answer.
a lot of activity, and I would imagine Deep Lab Cut is by now only one of the initiatives going forward. So how, you said your perspective is different. Can you just spell out your perspective again? If not the product, namely the most accurate rendering of 3D.
This is not the most
image.
accurate. This is not the most accurate. I'm focusing on usability, accessibility, and a number of sort of open source sort of spaces. Like a lot of the tools that are out there, honestly, the best and greatest stuff, I can't use it because it is like free for academic and non-commercial use. So the animators can't use it to make animations that they're gonna sort of try to get money from. Also, a lot of them use CUDA, which requires an NVIDIA graphics card. So if you're someone who's trying to get free motion capture, you may not have an NVIDIA graphics card. So a lot of the focus has been on just kind of like the aspirational goal, which I'll talk about in a little bit, is about the dream is making a tool that a 13-year-old with no technical training and no outside help can use to produce data that is the exact same data that I would use as a professional research scientist. And the idea behind doing that is, the principle is called universal design. If everybody can use it, then everybody benefits. Deep Lab Cut, God bless them, it is not easy to use. It is hard to get installed, and they don't, by no fault of their own, they're not interested in putting in the effort that would be required for a 13-year-old to be able to use their product. They're not targeting 13-year-olds, they're targeting computational neuroscientists. So again, they're a part of the procedure, because the way we built our pipeline, as long as the algorithm takes in images and spits out pixel coordinates, all the rest of the geometry will work just fine. So we've been focusing on the sort of core pipeline stuff, sort of like human tracking. This is media pipe, which is sort of quick and easy and hardware agnostic and friendly license and all that kind of stuff. Because I can think of a sort of a laundry list of other algorithms I would like to apply that would give better results, but it would be a divergence from that central goal to focus on that now. When we have something that sort of fits the job, is the right shape of data, and so talk about these quick limitations. This is just a little video that was made by Kylie Hardigan. Kylie is one of the 2 people in my lab who is sort of non-affiliated. with Northeastern. She lives out west, Colorado in the area, doing highline instructor. She's a skydiving instructor and a highliner, and made this video in the process of a preparation for a conference. And so she wanted to, this is her project, was go out and record people. Oh yeah, this is the actual ghost skeletons. This is what the talk is about, is you get these, like using GoPros sort of as this extra layer where you have such high resolution, you get these like ghost images, and neural networks have this sort of like known problem where they're really bad at knowing when they're wrong. So this has a high confidence value. It's like, yes, it's definitely a person. And so one of the things you're working on is trying to figure out how to effectively remove these ghost skeletons, which sort of fork out the data and make it so you can't actually track the person here, even though that's what you want to be tracking. And then this is, oh, Kylie was, that's back there real quick. So Kylie's a high diving instructor, skydiving instructor. And turns out skydiving, the most dangerous part is where you come into the ground. And so she wanted to set up cameras to record people as they came in for a landing. And she did get some data, but then encountered these ghost skeletons, and that sort of caused some trouble. But we, anyways, so we're working on that, figuring it out. This was also some fun thing that I worked on with James some time ago. Shout out now to Chris Chicalo, who is another one of the co-ops that started with me in 2020. He's done a lot of stuff. This is just one of them. And this is a bunch of GoPros looking at an axolotl and getting some pretty decent 3D data. This was Deep Lab Cut that did it. And it's sort of been this like, every so often it's like, wake up, get more axolotl MoCap. But it's, again, it's a divergence thing. It's like eyes on the prize. So focusing on the main, focusing on sort of like, focusing on what I'm actually trying to do, which is sort of make this core pipeline, get everything smooth, get everything clean, get the calibration, get the synchronization, yada, yada. Once it's at that point, add, putting an extra model to run through the synchronized videos, the geometry doesn't care, the pipeline doesn't care, the user interface doesn't care. So this is kind of the, so we'll get there. And also one last thing before, one more little piece of fun data. So this, so I mentioned so Kylie is a highlining slackliner person out in the West. So also is Philip. Seen here on a 1 kilometer long slack line that he rigged. Philip was one of the founding members. I think he's in the International Slackline Association as their director of safety. He, drives around the West Coast looking for high lines. And he comes to lab meeting every so often. And I have been sort of giving him experience on how to do this stuff. So this is not Philip, but this is his friend, and they're in the backyard. And visualization is very rough, but this is first being fully tracked. And this is showing their center of mass minus the base of support, which is biomechanical measurement. And then this down here is a classic space plot type of thing, where there's a rotation, so 0 is probably around here. But the horizontal is the distance of the center of mass from the base of support, and the vertical is the velocity versus base of support. So you can see it, this talented person who's standing on the slack line, there's this kind of phase plot thing coming out. This data is like close to this, I think, last night. So I don't have too much to say about it, but it's super cool, and I'm very excited about it. And doubly so because it was done by somebody who just doesn't fit, like Philip's a brilliant person, but he doesn't want to come to grad school. He wants to live out in the van and do this kind of stuff. And he deserves to have access to the same kinds of of opportunities and data and whatnot, that somebody who is willing to sort of live in the same place for 6 years and make $38,000 living in Boston is happy to do. So both Philip and Kylie, I think, are, I think the NIH calls it alternative education experiences. It's just, you know, when you start your lab through webcam, all of a sudden having people who are fully remote that you see like once or twice a year doesn't actually sound that bad.
I think there's a constant offset because
Yeah, for sure, for sure. The data comes out in the, yes, yes, calibration is always a challenge. So this is the last, I'm not gonna jump in there. So this is me back in my living room in a sort of a pretty grody looking but functional scan of my space that was just, I used my camera and a free software called Alice Vision, made this generated mesh. I think we'll show that. This is, that's the actual space. That's the eye tracker. And that's my house. So this is something that I built with basically light and linear algebra. Cameras pointed at my body, cameras pointed at my face, cameras pointed at my stuff, and then a bunch of free software in linear algebra, and you get something that looks pretty good. My computer is really having a hard time. But yeah, so we're in laser skeleton territory. One thing, this is another one of those like proof of concept things. It's like I got this done in preparation for the Vision Sciences Society. It's actually not there's some issues with the calibration, as always. But this is, I think, a really promising thing for the future. And yeah, and so now, FreeMoCap is now a thing, and lives in a bunch of different places. And it's now, the most shocking thing about it is that people are in fact using it. So FreeMoCap.org has been visited 19,000 times in the past year for 9,000 users. This is a map of where people are coming from. This is a Google generated thing, so there's no color scale, but America is 45 or 5,200 visits, and then scaling blue from there. And then this is and then the FreeMoCap GitHub now has, I think, roughly 2.2 thousand stars, which, if you don't know what stars are, I think the Google or the GitHub point thing. And this, so the blue one is FreeMoCap. The red one is the lab cut. The pink one is Cell Profiler. So you mentioned that, I was like, well, how are we doing? And it's not a competition. Wow, I mean. But then the green one is Image J. That's just like doing them on there to get some sense of scale. Now, obviously, so people are using it. And yeah, so there is also a, Discord, I gotta wake up. There's also a Discord server that has just crested 1,000 users in there. This is
just as you say, people are using it,
Mhm.
you obviously have no tracking what they're using it for, but would you know of any research use so far?
So I just got a DOI for the GitHub repo from Zenodo, which is like a European initiative, which we love that. And then you see people post about it, but it's, let's see, there's what am I looking for? What am I looking for?
Because it could be, 50,000 Chinese playing at home.
There's a lot of
with
people in China,
8-year-olds.
actually.
Yeah, I know. And so I just wonder whether you can track. the
So
research use.
people are posting, people post their stuff here, which is just in the server. I happen to know that this is someone who is working with a roboticist in Florida. And yeah, I don't have the data. The new version of the software has a little tab of like, send us a ping every time you use it. And so we do get a map. We've got stuff from 28 unique countries and like 90, 100 some odd unique users. And so we're now into the space of like ethical data, user data collection. So we'll have more information about that. Here's a short list of collaborators. So Chen Yu is developmental neuroscience, Yasin, developmental neuroscience. They like it. Kids don't remember that. Steve Harstead is a spine biomechanist in Denmark. He's submitted grants to do like 1,000-person spinal study type of thing. He wants to use FreeMoCap as part of that. Krista Kelly, developmental vision neuroscience, and Baptiste Casio is a postdoc in Frank Dermer's lab doing non-timely electrophysiology. He contacted me because of the original laser skeleton stuff. And he was like, maybe we can track their heads too. And I was like, funny, let me tell you. And let's see. Let's see. This is just a little overview of some of my favorite things that have come out of the FreeMoCap community. This is from a user named Danlo, who is a professional animator in London, I believe. And these are some of the animations that he has made. This is good old MPrib, Mac Pribble, is a doctor of physical therapy in Texas, PhD in UT Austin. He actually helped, so this is OpenSim, and he has a lot of experience in OpenSim and motion capture in general. And so when it actually got to this point where my grad student Aaron was like, hey, I want to use OpenSim, I was like, well, I don't know how to do it. So old Matt Cripple got on the call and helped him use it. And that's actually the skeletons you saw from before happened because of Matt. This is Matt learning computer vision because he came in with a background in movement science and all linear algebra, but now all of a sudden he has this platform where all the sort of the fun parts of computer vision are laid out to him. So he's really gone pretty hard on the calibration side of things. So that is him showing off his calibration tool, which is sort of built on top of the AnyFlows library that I've been using. It's sort of that calibration has sort of been in that space for a long time. Of like, it needs work, but that's the time. Turns out not. And so we're now in the process of developing the infrastructure to accept incoming help from external contributors. And I'm very excited to start pulling in some of Mac's work on the calibration side of things. Oh, I'm gonna have to speed up because I'm running out of time. I want to talk about my teaching stuff. This is Manitoba Mike. I don't think that's his actual name, but he's from Manitoba. His name is Mike. And he likes to record, this is his son doing various like sports movements in the garage. And love that. And this is from I just woke up one day and got a message from some high school in Ohio. And the students had discovered from Twitter the thing, and they found it, and according to the teachers, like they didn't even ask for help. They just sort of set it up, got it working, and set up a little mocap station, and asked the teachers to come do these little dances. So that's FreeMoCap, and I'm running out of time, so I'm just going to move on. I think we technically got to 1:30, and I'm going to use it. So yeah, teaching, right? So in the whole spirit, that's the whole thing. I have a lot of complicated feelings about teaching related to the complicated feelings I have about academia in general. I'm not going to go too far into it because I don't want to swear too much or get fired. But all I do have to say is I hope all of the professors have a very precise idea of exactly what tuition costs per year. And if you don't, you should look it up. And if you have feelings about that, we can talk about that another time. So I've been trying to figure out ways to develop teaching methodologies that kind of like embody a lot of feelings I have. I don't know if this is controversial, but it's something I've believed for my whole life. We don't do education well, like at a structural societal level. And basically because our models are bad. We have been doing education in roughly the same way since the Industrial Revolution. And it's sort of this model of like a filter model, where the idea is that people, it's designed explicitly as a filter, where we're supposed to be filtering out like chaff, and then we get the wheat, the cream rises. And the problem with filters is that they're very good at identifying the thing that they're filtering for. But there's a lot of different ways that you can be a good and valid person that deserves an education that may not fit into the filter. Signal model too is apparently that education is a lot of work to signal their quality to potential employers. And then the banking model is a pejorative term, sort of commenting on our education system as a transactional affair. Particularly in this type of space, it's give me money, we'll give you knowledge, and we will credential you by way of tests and grades and quizzes. Once again, just not my favorite thing. This is a great quote from Paulo Freire, who wrote Pedagogy of the Oppressed. Education is not about liberation. The dream of the oppressed is to become the oppressor. And so the question is, how can we develop educational systems that are about liberation and autonomy and gaining powers and skills that will free people from the sort of cycles that we're sort of living in, versus a screening device that sorts out individuals with differing abilities, thereby conveying information to the purchasers of labor. That.
Just to be clear, this is just for higher education, not for K.
I mean, I
would.
I teach at higher education.
Yeah, okay, I just wanted to clarify, as a former high school teacher, I was just kind of wondering. Because you don't pay for K through 12.
You don't pay for it, but it can still be bad.
Yeah, absolutely.
I just
But this is
basically,
specifically for higher education.
I'm speaking specifically
Yeah,
about higher
got it.
education.
Thank you.
But I kind of think that some of the same principles apply. So the idea of like, so there's this term pedagogy, which we all hear over and over again, which Latin roots is the teaching of children. Andragogy is a word you don't hear as often, it's about the teaching of adults. And pedagogy is all about the sort of like teaching people that don't have an established sort of like personality yet. So that's your lower education. But once you're in college, it's really, people have the opportunity to be more independent. And so I think that, we have this sort of industrialized system of education, lectures, tests, grades, quizzes, degrees, like sort of, churn them out, sort of separate them, credentials them, call it a day. But we know that humans don't learn like that. I mean, if something happens, the people who make it through the gulag are certainly like good at whatever tasks are needed to make it through the gulag. But that doesn't mean that they're being served in an educational perspective. It just means that they're able to jump through the hoops that we sort of put out for them. So I've been trying to find sort of iteratively over the course of the 4 times that I have taught biology 2299 methods for engaging with students that is sort of more respectful of their adulthood. And ideally moving towards this fluid pedagogy. You probably can't read this too well, but if you just Google andragogy pedagogy, it's pop up. And this is about just self-directed learning. Like you don't like, this is more like mentor-based self-learning, and then pedagogy or whatever is sort of a higher level. And so I think that we should be pushing up in that direction and focusing on, so emphasize skill building, finding intrinsic motivators that may not be shared amongst members of the same group. So here's a space to work in. Which of these things appeals to you? And then encouraging that kind of behavior. That's like a Montessori model. Mentor-based collaborative efforts. Like there is no point in making them all work on their own. It's like get something together, like let them work together, let them share effort, let them share work. And build artifacts, like things that you can sort of take with you. A lot of the stuff that I was showing you, all these talks and videos and stuff like that, happen because people in my lab are always producing these sort of like outputs, like little video outputs that represent an artifact saying, here's the work I'm doing, here's the state that it was in at the time that it was produced. And then it's de-emphasizing lectures, tests, grades, quizzes, majors, like all these sort of like artificial sort of things. And in the spirit of more specifics, I want to take you on this very quick tour of my latest iteration of Biology 229, which this year I am running almost entirely through a GitHub server. So here's the syllabus of the class as a README, and there's automated pipeline set up that whenever things get pushed to the main branch of the GitHub, it goes to this website. And so you can have things like, here's all the collaborative notes for each day of class. Here's some stuff about poster presentation. Here's some how-to guides to do sort of various things. And then here is the sort of like some of the more content of the class, like teaching them how to summarize, find and summarize papers, which is the actual sort of topic, the teaching outcome of that class. Finding papers, summarizing them, and then pushing through to the GitHub repo. And my class this year is very nice because it's fully half data science bio and like other like behavioral neuroscience and other forms of bio. So there's a really nice separation there between the comp sci data science folks and the more science focused folks. And where that gets really exciting is in the sort of rather ambitious plans that we have for the poster presentation, which so about a month ago, I brought in a bunch of cameras and set them up in class, and then half of the class was sort of, actually a third of the class was doing some code stuff or some work stuff, and then everybody else was kind of cycling through and doing this data collection thing. So that's me. Just always easier to show myself. I did get permission from them to share their data in public, but it sort of just feels more comfortable to look at myself. And so what we did is, so we were able to collect full body motion capture data from 8 students in class doing sort of various standing posture tests, so standing on 1 foot, standing on 2 foot, stand on 1 foot while holding a weight that's 20% of your body weight. And the plan is to take that data and produce the posters that are the outcome of the class from that data set. So that we'll have the posters, instead of being presented sort of from a like find a paper and present it as if it's your own, is going to be find a sort of small bite-sized but very real research project that exists within the data that was collected, and then sort of pairing up with people in the class to have sort of that the posters will be a combination of sort of literature review on the topic, as well as sort of simple analyses of the data that we collected together in class. And so this is now a Jupyter IPython notebook that you could host on Google Colab. That I am writing with people in my lab because, as you saw before, this is very similar to work we're doing on our own. And then writing sort of a simple data just to sort of pull stuff out. And sort of then the task of the students is just to go through there and sort of change the names to frame numbers and stuff like that. And so this was a nice, this is the heel of, this is Trent in my lab. This is, you came in and did some data collection. This is his heel, this is his toe, and the green is the center of mass. We wrote this code together in class. And so now this is showing that, he is in fact standing with his heel, this is center mass of his toe. So they can go through and then pull that data out and then sort of put that as part of their posters as they're presenting them. And so that just feels much more aligned with me. It's a much, because that is like doing research like that is it's real work, and they're learning real skills, going professional grade. Show You know, this is a project board, a Kanban board for the poster project that's sort of hosted through the GitHub. These are all issues and different sort of components of the tasks. You know, this is, you know, the issue for doing the literature review, and this is the student who made the Google Doc for that. And then the data processing, you know, are sort of pulling it all together for a sheet. And so we'll be able to, because GitHub is literally designed for large scale distributed asynchronous work on code or documents, we should be able to sort of use this as a mechanism for them to develop their posters, which will provide, and then sort of have a record of everything. So you can just have a multi-author poster, like all posters are. And so the hope is to sort of, you know, in addition to being sort of like legitimate research projects, like the question that they're asking these posters, I legitimately don't know the answers to those questions. I'm excited to find out, while simultaneously teaching these like actual, real, relatable, transferable skills. Like this is not Canvas. Like this is GitHub. This is a real thing, and the skills that they learn here can be transferred to any other context. And I think that's it. And so in closing service, I'm on the DNS steering committee and other stuff, whatever. But the services that I really am excited to moving forward, I'm also supposed to have this colloquial noise, I'm sorry, is really trying to facilitate more of that kind of thing. So developing more methods to give specifically undergraduates, but graduate students as well, very like legitimate, real work, organized in sort of like a club-like interaction. I'm going to speak at the Neuron Club on November 10th, and trying to sort of, you know, have the students kind of connect to themselves, work on things themselves, organize in the sort of traditional methodologies of the open source community, and from that develop generally applicable skill sets of, you know, GitHub-based project management, Python-based analysis, and doing it in a way that's sort of driving them towards autonomy. Because what happens, and I'm sure everyone, the professors experience this, everyone tells these students from day one, your classes aren't enough. You got to go get research experience. You got to go get real lab experience. Then they come to us and they say, hey, we're real lab experience. We say, well, I don't know if I have work for you because it's, you know, like, because I don't. And so the hope is that by sort of embodying some of these sort of techniques of decentralized work, specifically the kind of work that is designed to, because open source world, most of it's made for this. And so that's kind of what I want to keep moving along with. I've been working iteratively on inquiries. That's my 4th time teaching it, and I'm finally trying to get to something I think that works, which is exciting because it is very hard to get first semester freshmen engaged in the class format. That's another problem. Classes are too short. There's not enough time in the semester. There's not enough time allotted. And we know that to do real work, to do research, it's an iterative process. It takes longer than a semester. So that's why I'm excited about the potential of sort of like clubs, where the students can kind of work on their own sort of self-motivated projects, and then to sort of have, you know, me or like, you know, grad students or postdocs or upperclassmen, people who have been doing this stuff for a couple of years, to sort of smooth out the edges and get things moving forward. So that way that it could theoretically grow autonomously in a way that is not bottlenecked by the PIs who have the experience to actually sort of make those calls. Because again, the open source community is designed to be this large scale decentralized collaborative effort, theoretically without sort of centralized bottleneck sort of authoritative figures. Maybe, we'll see. And that's about that. So thanking people in my lab, my postdoc, Aaron, my grad student, Philip and Kylie, and then Chris and Jack at the beginning, and then a bunch of people whose names I didn't know. Thank you.
I have a quick question about your audience or possible audience of your program. And what struck me was the dad watching the kid do athletics. You've got a very good platform for golf.
Yeah.
Do you know how many people really want to study their golf swing?
Yeah, I've gotten.
Way of, like, every club would have their own little one camera, here's a golf swing, and they'd have the pro dissect it.
The number of applications for free, high quality, easy to use motion capture is high. I get contacted by people regularly saying like, "Hey, do you want to like work on this golf thing?" And it's like, I don't, but
Yeah.
you can.
Right. Well, that's the point. So
Exactly. And it's always been interesting because at this point it's starting to stabilize, but for a very long time, every time I would mention it to someone, they would have a new application that I hadn't thought of. At this point, like I've heard golf, but like it's, it's like who needs to study human movement? Like anybody. And anybody, and now, you have like independent animators, game designers, coaches, whoever, for whom motion capture was just 100% off the table. The best we have now are these like $5,000 IMU suits, which are like as good as they can be, but they're not. That's not the future. It's like an 8-track. And so what I've been seeing with this is when I show it to people, oftentimes you just see the gear start to move, and it's like, oh yeah, well if I had that, then I could do this. If I had, then I could do that, and that's the dream. That's why I want to focus on tool building more than the paper publishing. I mean, you have to publish papers. Students are going to publish papers. They need that, but I don't really feel the need to push that particular cart on my side, given the amount of effort that I don't have available. I find myself far more motivated by people who are waiting in the wings, working with this in its sort of current janky form, and just sort of learning more and more about how to build those tools. And that is something that I think it just kind of has to be me right now. I've tried offloading it to students and postdocs and other people, and the reality is that it's not time, because I took this long to get able to do this, and I'm working with my friend Endurance, who has 18 years experience or whatever as a software developer. He's teaching me how to write better code so we can turn this into a proper open source project. And the reality is that if you're trying to build a tool, you can't ask someone who hasn't had experience using tools to build the tool for you. You have to build it yourself and then give it to them to train on. So
Just a sort of a comment. Of course, I'm totally intrigued by facilitating more and better motion capture, but I think they're dismissing the publishing papers a little too extremely, because it's not about publishing papers, but it's actually about making use of the recordings and find out what movement and how the brain compose movement is about. So I think you're sort of pushing this a bit too far into a meaningless exercise.
if I had a couple extra people in my skin, I was more than happy to spend the time doing the research. That's the whole point of this, to do the research.
Exactly.
But-
So I'm just trying to prod you to, tools are good, of course, we all need them, and there is a definite need for this type of improved and more easier data collection. But it is about the scientific insight, not about publishing paper.
I think that with the available effort that I have in my life, the biggest impact that I can have on the scientific and non-scientific part of the world is to make the tool that allows people to generate the kind of data that I think they need to be generating. Because the reality is that I think neuroscience is also kind of mostly bad, and mostly doing this hyper-reductive work that is not going to turn the corner into natural behavior. And so I go out there and I'm doing this laser skeleton stuff, foot placement kind of stuff. And I can publish more papers and I can ask more questions, but the reality, my actual sort of, scientific insight is that it's the tools that's the problem. It's people need to be able to collect the data. And so then, honestly, a lot of them are better scientists than I am. Like my friend Kate Bonin, she's a more careful, more nuanced, more sort of precise, more sort of question-focused person than I am. And I would rather make the tool and give it to her and let her do her work. And then I can focus on the things that over the course of time I have determined is my unique capacity, which is sort of finding these sort of like techniques and tools and whatnot. And I think that it's a mistake that we tend to make scientific community to sort of publish on software. I think people just shouldn't do that because it takes so long and you're instantly obsolete. Just write the code better. So it would be beautiful if at some point things stabilize to the point where I felt like, or if the open source aspect of this sort of picked up to the point that I could feel like I can step away from the development side of it and start doing the research again. But we're not at that point. If I stop writing code, the code will stop getting better, and there's too much work to be done.
Yeah. So where do you see the project going 5 years from now? What's the dream?
So there's always these models of, so the dream is self-sustaining, decentralized, open source project, like a proper sort of like, you can pip install FreeMoCap, but it's not quite pro grade. But like, pip install NumPy, Pandas, Seaborn, IPython, Jupyter, like all of these are sort of these like massive open source projects that sort of have their own governance system, have their own community of people. And I would really like to sort of continue that process of developing like FreeMoCap to be that kind of a platform where people can come to and sort of like, have it can build its own, have its own documentation that has its own educational structure, and sort of, have it be the kind of thing that I don't have to be the central figure for it because it will have picked up enough Matt Cribble et al.'s that will be sort of, I can sort of just be managing stuff. Although I will always, I still use it, but because one of the things also I didn't mention on this side of things is the process of doing like the GitHub-based class that's producing these artifacts. Like that class, it's sloppy. It's like it's first time trying it. I'm learning how to do it while I'm doing it for the students, which is kind of exciting because then like we're learning the same thing, which is pretty fun. But the hope is that by doing this sort of more directed one-to-one kind of teaching stuff, mentorship and things, that will produce artifacts and knowledge bases that can be more generally used in this UL college, whatever self-directed learning thing. Because if we in the ivory tower, where we are constrained to be, if we focus our effort on producing more sort of educational, artifacts to people, and have them be written and share them in a way that sort of serve the needs of people. Like we're not coming to them and saying, here's the hard questions that we have decided you should care about. We're coming to them and saying, here is a tool that will allow you to do whatever you want to do. And secretly, if you use this tool to record yourself dancing in your bedroom, you accidentally gained access to machine learning and computational geometry and neuroscience and biomechanics. Like Matt Cribble, with background in physical therapy, now he knows computer vision. Like that kid in Manitoba who's doing stuff in his backyard. He's just working on his hockey string. Like, whoops, you just learned how computational geometry works. And so that's the dream. 5 years.
I just recently heard from a clinical colleague that several years ago, Harvard tried to revamp its medical school education, which of course fits as much as possible that extreme of facts, conveying facts to students before they are then allowed to see patients, what they really want to do. And so in the spirit of going away from this rather droning fact and teaching, they reinvented the education And the whole thing was under the super or under the drive of the president or very high level person. And after a few years, the whole thing collapsed and the responsible person had to go, and they're back realizing that teaching is both mainly conveyance of facts as well as the creative, engagement.
Sure. I think we
So
are,
I'm just saying that you're not the first person
I know.
who is veering away from the facts.
Yeah, and I think
conveyance to
oftentimes, I
something.
mean, that's structural, right? That's a lot of times like structural inequity, things like that happen because you are constrained to behave in a certain way because of the structure of the society that you live in. So if you're in a medical school and you're trying to say, we're not going to do classes anymore, it's like, that's a lot of machinery for you to push back against.
No, it was pushed back. It was not the machinery that prevented them from doing so, but from PSA, from my clinical brain, it was not successful because the traditional facts
I'm
should
not saying
be
stop
thrown
these
out of the
classes.
window.
I'm not saying anyone should do anything different than they're currently doing. I'm doing something that I think fits a need that doesn't exist yet. So like, I'm not trying to like burn it all down. I'm trying to build an alternative. I happen to think it might already be burning, and I happen to think that might not be something I'm too concerned about. But I don't feel like, I'm not saying like, get rid of universities, stop teaching classes. We don't need tests anymore. I'm saying we need alternatives and alternative forms of education, alternative ways of engaging people. Things will grow organically. Some things will work, some things don't. This is a new context of something that I haven't seen before. I have sort of joined forces and sort of, encountered other people who have sort of aligned perspectives. And things like neuromatch, I don't know if you guys want neuromatch, it's another sort of like organically grown kind of thing. And it's not about replacing anything. It's not about trying to say, it's like, hey, this is the wrong building built in downtown Boston. It's saying, I'm looking at a gap, a thing that I want to see and I'm not seeing it. So I'm going to build it and we'll see what good it serves.
But let me just say, because I just made a case for fact-based teaching, but in project-based teaching, we use a different word for your approach here, for the teaching adults versus teaching children. I actually think there's a lot going on that we may not have encountered in certain classes and I'm certainly
Experiential
attempting
learning,
to do
there's all
such
this
a
stuff. Like
right?
there's,
So just to not throw out the baby with the bath in both directions, I appreciate your suggestion completely. I would subscribe it, but I would say I am subscribing it in my own teaching.
Great.
And I think others too, but I don't know. And I think that's what you should keep in mind. I don't know what you are yet subscribe to for you, and there are people. So I think you shouldn't label everybody else doing something.
I never did. I assure you, it was never my intention to say anything about anybody else's teaching capacity. Like, I am describing things that I have encountered in the educational system and describing my approach to teaching moving forward. And if anybody else is interested in learning some things, great. If you say, oh, hey, here's the thing that I do that's aligned with your perspectives, happy to hear it. I'm not saying anyone should do anything different from what they're currently doing. I am describing what I am doing. So facts are great. If what you're doing, you need to know, like if you're trying to, whatever OChem, DChem, whatever that is, like I'm sure there's a lot of learning to do, kind of prepare for the MCAT. That's another constraint, not a structural thing. Like, I'm not doing that. I'm teaching biology 2299 to first semester freshmen with the edict, teach them how real science works. And so I'm working with those constraints to try to serve that teaching goal in the most legit, real, and sort of morally aligned way that I can.
I'm aware that we're quite we're running out of time, so I'll just ask this quickly. But I was curious to see what sort of feedback did you actually get from like students on this and stuff, and like based on that, how the course like evolved over times. Because I know I would have definitely benefited from this from my undergrad, because it wasn't until I got to master's level that I was like, wow,
Yeah.
biology involves a lot more coding than I ever thought it does. So I can see the merit of having more.
Yeah, I think the students in my classes over the past 4 iterations of class have, I hope, and when the teaching evaluations are always good, appreciated the chaotic aspects of like the sausage being made, as they say. Because it is iterative, and I am constantly sort of like, hey, this is what we're gonna do in class today. It's like, ah, shit, that didn't work. Let me think on my feet. And with the feedback that I've been getting from students is that they appreciate the honesty of figuring things out up on in front of the stage. Also, I'm a bald white man with a beard, so I can get away with a lot of things that people who don't share my demographics can't. And I think that the students tend to have appreciated, like in my experience, once you speak up, appreciate feeling like they are a part of figuring something out. So I'm very honest with them about like what I'm doing and why I'm doing it, and saying like, I've never done this before, we're gonna try it out. This year, possibly because it's only 10 students, is the first year that I feel like we're actually, I mean, that's not true. I feel like I've done good stuff in the other classes, but this one feels like it's actually moving in a very interesting direction. Part of it is the state of the FreeMoCap software, the ability to go in there and collect 10 subject worth of full body motion capture data in an hour. And part of it is also me learning, GitHub and that sort of organizational tool. It is always hard to say with freshmen, but like, if I say, are you enjoying this? I get like, which like is equivalent to backflips for some of the bits. So it's, I think they, unless they're lying to me, then they are enjoying it. And they weren't lying, they didn't want to just not say anything. And I told them too that it's, if the work, if the research projects are moving forward and they're inspired and they're enjoying it, we can keep working after the class is over. I think that is very motivating to a lot of them, because one of the things, we ask these students to pour their hearts into assignments. We look at it for 5 minutes, give it a letter grade, and throw it in the trash. And that is the educational system that we tend to have. And I think that that's very demoralizing for a lot of people. And so the ability to feel like they're working on something that has legs, so to speak, I think is, I think they're into it.
So if you wanted to use the software,
So you would need cameras, but I can get cameras. And then the software is all free. So FreeMoCap.org is a link to the GitHub. And then there's instructions that are like kind of user friendly. And then the place I tend to focus people towards is to go towards the Discord. On the website, there's a Discord, your Discord before.
yeah.
Ask your questions on there. Also, just get in touch with all. Don't, but FreeMoCap.org is just find me on the Discord. Yeah, and then the only thing you would need physically is the cameras, and I actually have like a pile of them in my house, and I'm happy to share. No, you don't, because the instructions are designed or written from the perspective of someone that has never done anything before. So you will have to type things and push enter, but I will tell you exactly what to type and when to push enter.
I was also just out of interest. I'm Sam, by the way. I'm a heat lab.
I'm gonna shut down the Zoom, but thank you, Zoom people. There's a lot of questions, and I can't read them, and I'll read them later. And thank you for being here, and I love you, and goodbye.